Okay, today we're going to look at laws of indices. Just to remind you that indices is the plural of index, and index is another word for powers. So we're going to look at three rules and some examples of them. The first one is multiplying powers with the same base. All three rules only work when the base number is the same. So in this case, the base number is 4. If these two were different, this rule wouldn't work. So to explain why it works, I'm going to take this example here. 4 to the power 3 multiplied by 4 to the power 2, or 4 cubed multiplied by 4 squared. If I write these out, 4 cubed means 4 multiplied by 4 multiplied by 4. 4 squared means 4 multiplied by 4. And I'm multiplying those together. So the result of all those being multiplied together is going to be 4 to the power of 5. Now, an obvious shortcut here is to see that the resulting power, 5, is the original two powers added together. So the rule, when you're multiplying powers of the same base, you add the powers or the indices. So my second example, I'm not going to write them out longhand because writing out 3 to the 9 and 3 to the 11 would take a long time. So I'm just going to use the rule and add the powers. So that would be 3 to the power of 20. Notice I'm not actually working out what 3 to the power 20 is. I'm just leaving them in power form today. The rule works with negative indices as well. So 7 to the power negative 3 multiplied by 7 to the power of 5 is 7 to the power of 2. And the general formula for this rule, if I'm using algebra, x to the power a multiplied by x to the power b would be x to the power of a plus b, the powers added together. The second law is dividing powers with the same base. Once again, I'll just stress that the base must be the same. Once again, for the example, to show why it works, it's good to write these out longhand. So 4 to the power of 5 is 4 times 4 times 4 times 4 times 4. It's actually helpful to write this division in fraction format. So on the bottom I've got 4 cubed, which is 4 times 4 times 4. 4 divided by 4 is 1, so I can cancel out matching 4s like this. And I'm simply left with 4 times 4, which we can write as 4 squared or 4 to the power 2. Missing out this middle section now, I can see that the rule, when I divide by powers of the same base, I subtract the powers. 5 subtract 3 gives me 2. Going straight to that rule here, 3 to the power 12 divided by 3 to the power 7 is 3 to the power 5, as 12 takes 7 is 5. Works again with negative numbers. 7 to the negative 3 divided by 7 to the 5 is 7 to the negative 8. So writing this in a generalized format using algebra, x to the a divided by x to the b would be x to the power of a minus b. The final law is when we're going to raise a power to another power. So I've got 4 squared to the power of 3. To the power of 3 means multiply by itself 3 times. So that's 4 squared times 4 squared times 4 squared. If I rewrite the 4 squareds as 4 times 4, 4 times 4 and 4 times 4, and we're multiplying those together, you can see what I end up with are 6 4s all multiplied together by each other. So that is the equivalent of 4 to the power 6. If I go from the start to the end in one step, you can see I've got this 6 by multiplying these two powers together. 2 times 3 is 6. So to cut out the working and go straight to the answer, on this example, 3 to the power 4 raised to the power 6 will be 3 to the power of 24. That saves an awful lot of time going straight to the answer. Works with negative numbers. 7 to the power negative 2 to the power of 5 will be 7 to the power of negative 10. So to put this rule into an algebraic format, a general format, x to the power a raised to the power b will be equivalent to x to the power of a b.